let's start. So we are recording. The floor is yours, Jeremy. You are
Jeremy,
the
please
boss.
go ahead.
Oh, okay. Let me full screen this. So, the AI Engineering 4D Community Show and Tell. We have done 20, correct me if it's 21, over the last 3 or 4 years. And as it says here, educator focused. We've got some QR codes there for things that we support. And can we do the next screen? And it's by Jeremy, Marcelo, and Marco. I'm a K-12 educator. I've been doing ML for about 10 years in the high school classroom. And I'm from Canada. Marcelo.
Okay. Good morning, everyone. I'm Marcelo Rovai. I'm a professor in Brazil, and in fact, I live in Chile, and I used to talk and to do writings about embedded machine learning and TinyML and Edge AI, and also generative AI at the edge. Marco?
I am Marco Zanaro. I'm a research scientist at the International Center for Theoretical Physics based in Italy. And I have been working on TinyML for the last 7 years. Really happy to be here today and to listen to your interesting presentation.
So just about our show and tell, I think we're on show and tell 20, 22 countries, 43 student representatives. Next screen. And today, in slightly different order, we're going to have Karen present first, then Joseph, then Franco, and they will be introducing their presentations. And is that the last screen? Don't forget to go to the mlsysbook.ai, which is the main page for reaching 1 million AI engineering students. So, Augustina, do you mind trying to take over the screen?
Yeah, sure.
And introduce yourself.
Okay. Let me just...
Yeah, this always takes a few minutes.
Can you see my...
We're good? We can see it?
Well, welcome. My name is Agustina. I'm from Argentina. But I'm here today with my team, Karen, Aaron, and Charlie. And I'm going to talk about TriatoBox, the first line of defense against the Chagas disease. Currently, there are 75 million lives at risk. The World Health Organization recognizes that there's an incurable chronic phase that destroys the heart from within. But what is Chagas, really? Chagas disease is spread by the kissing bug. That's not so bad we see in the images. The kissing bug is attracted by your body heat. It bites and leaves the same trace as any other common bug. But it leaves its eggs into the posture. No one notices a thing, and the tiny eggs travel for a long time. It could be months or even years, even before any symptom appears. But once you feel it, it's already in the heart, and it's too late for any kind of help. The heart gives in, and there's still nothing we can do about it.
Did you know that millions of families...
That's why we presented this project in the Paul Prize Ecuador competition, getting to the nationals even, where we were given lots to learn and keep the project growing. So here's a little video my teammates presented for this event.
Did you know that millions of families in Latin America sleep every night next to their greatest threat on a wall like this? Chagas is a deadly, silent, and neglected disease to this day.
Meet TriatoBox. It is not just any trap. It is an intelligent guardian. We use artificial vision and this small brain for the detection and elimination of the kissing bug instantly, even in the dark, with no risks, just technology saving lives. For every TriatoBox implemented by provincial councils, municipalities, or parish boards, the national healthcare system saves large amounts of money on chronic treatments. It is a victory for local budgets and a second opportunity for families. Innovation that protects.
And families that can finally sleep peacefully. We are TriatoBox, and we are going to win the war against Chagas disease.
So, lots of people sleep next to the kissing bug, but also millions of them work next to them too. Ecuador is known for the banana and cacao industries, with thousands of people working those plantations. The kissing bug happens to play very, very well between crews, which puts all those workers at high risk. The Ecuadorian law makes the employer liable to ensure the workers' conditions. It is often that operations have to shut down because of inadequacy, costing hundreds of thousands of dollars daily. We also have the cost of insecticides, the primary pest control base, that not only are pricey, but also present a hazard for the workers and the products. Here's when TriatoBox enters the scene. We present an AI-powered intelligent guardian that functions as a technological insurance policy. Today, industries and homes fumigate and apply chemicals with any real data, honestly. The campaigns are more reactive than anything. We offer a precise and autonomous detection of the kissing bug without any chemicals, only engineering, working for the proactive prevention of this. We use the Nixla Vision board with an integrated camera, which was donated at TinyML4D, which was a huge help for us. We train the model using Edison pulse, so it can detect kissing bugs and report it via MQTT to web division. Our prototype offers a mobile app with real-time notifications and a history per device, so you can track the bug from your smartphone, and also a dashboard showing a heat map and outbreak alert for those in charge of government and industries. 4,804 images were taken at the Center for Research on Health in Latin America at our university, the Pontifical Catholic University of Ecuador. We uploaded the data, normalized the images, processed them using an RGB scale, and utilized a transfer learning algorithm optimized for image classification, the model MAP-V2. This algorithm not only trains the model, but also optimizes the neural network, so it fits within the tiny board and its limitations. Then the model is quantized, breaking down the connection weights from 16 to 8 bits. All of this gives a more optimized model, not only in its functionality, but also in its size. But don't forget, we are working in the tiny end of machine learning. And honestly, results were great. The model ended up with an accuracy of 97.5%, so more than enough to deploy that to our little Nixla Vision board prototype. I've been talking a lot about this device, the solution, but how does this actually work? Okay, first, the trapdoor remains strategically open, on standby, waiting, and the moment the kissing bug appears, the model can recognize it in milliseconds. The next steps we're working on are capture and elimination of the bug, sealing the box, and neutralizing it through oxygen deprivation. Think about all these chemicals we talked about it. They're gone. And then sending an alert to the app install data, retrieving the localization of the data. Sounds a bit much, but we are backed by some scientific and technical expertise. We are working with the Center for Research on Health in Latin America on the health front, TinyML4D in the technological area, co-creating in the business side, and lots of professionals that back this project up so we can win the war against the Chagas disease. Our project's impact is aligned with 3 Sustainable Development Goals. But for our first year only, we aim to achieve 7,900 workers and community members directly protected, covering the third good health and well-being. For the next year, industry, innovation, and infrastructure, we aim to have almost 1,600 IoT nodes deployed, creating first epidemiological network. And for the eventual sustainable cities and communities, we are pointing to 100% replacement of chemical fumigation with clear monitoring in pilot zones at least. We are the TriatoBox team, and we were glad to start our project today. So we can keep growing and reaching and protecting even more people than we can do. It's been a pleasure, really. And now I think my teammates will show you how the project works. So if Karen is okay with taking over the presentation.
Okay.
Great, great. Congratulations, Agustina, Karen. Oh, fantastic, fantastic. Yeah. And you know, by the way, I would like to see this project in live. Huh? We are organizing a workshop in November in Ibarra, Ecuador. So we will be together there.
Yeah.
So
Karen will be here. I will not. But Karen now is going to show you how the prototype works.
And by the way, sorry, before the questions, Jeremy, I don't know if you know, guys, but you guys know, but this is a very, very, very important research. I mean, research about the Chagas disease. The doctor Carlos Chagas is a Brazilian guy, and this is the single research in all human history that they went from the vector to the disease, the complete cycle. Never, we don't know. It's the first time that they Carlos Chagas, this doctor, I mean, their research came from, they found the bug, they found the vector. That's in fact the let's say the small thing inside the vector. The vector is the Trypanosoma crucis, in honor to Osvaldo Cruz, is another very bright and famous Brazilian sanitarist. So it's very, very exciting to see this.
Yeah, it's a very popular disease.
Yeah.
Sadly, but we think that the impact it has is for the more vulnerable people. Yeah, because not everyone sleeps next to it, not everyone works next to it, but the people who do are in a very vulnerable position.
Yeah.
So we aim to fix that from source directly.
How you call the bug in Ecuador? In Brazil is Barber, the guy that
for Spanish is vinchuca.
Como? What?
Vinchuca.
Oh, okay. In Portuguese, barbeiro.
Karen, are you taking over the screen?
Yes. Karen, you go.
Okay, this is our prototype called TriatoBox. We use the nuclear vision to detect and identify the insect inside the trap. Through these entrance, the insect goes inside the box. When the insect enters the nuclear vision, analyzes it and verifies if this kissing bag vinchuca. If the insect is identified as a kissing bag, the door closes automatically and traps it inside. After that, the insect is eliminated inside the trap, helping prevent the spread of Chagas disease. Next, we will present a short video demonstrating how it works.
Oh,
Okay,
there we go.
Nice.
We are having
so
little
helpful.
issues with the audio, but that's how it's supposed to work. The prototype. I mean, there's nothing to bait the insects inside. The insects are attracted by human body heat. Yeah. So so in the coastal area of Ecuador, where all this industry happen, and mostly in every place that Chagas disease is spread, there are very warm areas. So placing them strategically would be the key factor for them working optimally. Yes, it can be emptied and then reused with no problem. The thing is, if a TriatoBox will work for only one kissing bag, yes, you can empty it and reuse it for another bag. So because it's already trained. And I don't think you will use it again if with a bag inside, because you will be collecting bags then. But to each their own.
Awesome.
Well, that's a great presentation. Aaron, was Aaron going to pop up, or basically, are you done?
Yes, if there is no more questions, we are done.
We've got a couple minutes for questions before we should go on, but incredible project. It's great to see the NICLA vision working, and the fact that our group, which was called AIEng4D, gave you that. That's an amazing project. Anything from people watching? Any questions? Because a really good presentation.
Yeah, I have another follow-up question. My name's Kari. I'm part of the engineering group too. So I was just curious, are you all making this for like in production? Is it being disseminated? Did you say there's something like 1,400 units that are being disseminated or something like that? Curious if it's like out in the world.
No, first of all, hi, Kari, pleasure. But it's not in production yet. We are still in the prototype phase of it, polishing details and working on it still. Currently we are with the elimination process. We already have the hardware, we already have the train model, but we are in the elimination phase. We are working on it actually. And we are having laboratory tests for it, so we can really ensure the correct functionality.
Awesome.
Wow.
Great.
Well, good luck, and hopefully this helps out, because great explanation. Typically we have some time at the end of the show. Can we switch over to the next presentation? And thank you so much for presenting, all four of your group.
Thank you so much. It's been a pleasure.
What do we have here? Joseph, can you get your mic on?
Yeah, Joseph here. I'm trying to share my screen. And great presentation, guys. That was very good to watch.
Speaking of which, Augustina, do you have a link to TriatoBox? I guess I could just Google it.
Joseph, you know that you have a button, no? But a button to share the screen. It's near
at the
camera.
bottom, Joseph.
Yeah, near the camera.
Okay, yeah. Thank you.
It's in construction actually. We've been, if you Google it, you probably will be linked to the Instagram posts about the Hulk price, because until recently we were very consistent and inconsistent. So you won't find a website yet. But
Okay.
we will have the link to the project mailed to you soon.
All right, can you see my screen, please?
Yes, we can.
Great.
Go ahead, Joseph.
Thank you very much. Okay, sorry for keeping you waiting, and thank you for your patience. I'm Joseph from Nigeria, and I want to thank the TinyML community for giving us these kits. It's really helped learning. my supervisor was the one that applied for it. His name is Dr. Shegun Adebayo. He's not here because he has other things to attend to, sadly. However, I bring his greetings. So thank you very much on that note. So we got several ESP32S3 Sense boards and kits, right? You know, funny story, I didn't know the antenna was very important, so I misplaced mine, but it was able to give me another one. Yeah, so this project was one of the projects we did. So he asked that I present this because, you know, to show what we're doing with it. We did several things. So this was one of them. I worked in a group of 5 students and I was the group leader. It was a class project to create a database for plants in the school. And, you know, in this age and time, right, data is invaluable. No matter the kind of research you want to do, no matter your idea, if you don't have enough data, you may be limited, right? So what we wanted to do was to get a database of all the plants in the school. Unfortunately, we couldn't get for all the plants because over here in Nigeria, we have several kinds of plants, but we did for the very popular ones. And the end goal was to deploy it so that you can just put your camera, your ESP32 camera, and look at the picture, and then it shows you and tells you what plant that is. So that's what this project is about. Let's get started. All right, so these are the contents of the slide. I just going to move it. So why this project? Like I said previously, data is very important, right? And if you don't have data, it could limit the kind of research or your ideas you want to first get enough data. So that was our contribution. And we wanted to use TinyML to solve that problem, right? And to deploy it so that it's actually a deployed solution. So we have you can see over here, we have the sensor input, and then that's the camera, and then it goes into the ESP32S3, and we can easily tell, right, what plant it is. So if you put it, let's say, in front of a popular flower that we've already annotated, then it can tell you, oh, I think it's this flower with this percentage of probability, right? So our core question was, can we do all of this on a tiny microcontroller? Because in this day and age, image classification is a norm, right? It's not something new, but the new thing was if we could get it working on our TinyML kit, which is what we did. Right, so we, like I said, I worked in a group of 5. We were able to gather about 600 plus images, right, of plants, and even some of them, the fruits, because we wanted the database to be robust, not just leaves. We got leaves, we got flowers, we got the fruit pictures. And then after that, we wanted to put everything into AIEng4D, right? AIEng4D is a great tool online for this kind of task, right? You just upload the images, you train it, and then it does, you just tune the parameters, and then it does the training, and you can download it, right, as an Arduino file that you can run on your Edge device, right? So we ran into an issue. Most of the pictures we took them with iPhones, right? And they were saved as HEIC images, some of them as DNG. So we had to first take everything to Google Colab, and then we processed the images to convert them back to JPEG, which was suitable for AIEng4D. We did a training afterwards, and then we're able to deploy on our device. So, like I said, the hurdles we faced, right, the conversion from the HEIC formats and the DNG formats, and then we're able to use Google Colab for that, using the pillow, the PyHef functions, and all of that. And after converting and resizing, we're able to put them, although some images failed for reasons we couldn't explain, but majority of them were able to scale through. So we still had over 600 images to work with at the end of the day. So I have this was the final confusion matrix, and it was 84% in accuracy, the final F1 score. That's the blend between the false positives and negatives, and we're able to get this high score. So after deploying, so I want to do a sort of live demo for us. Let's see how that's going to work. Can we still hear me? Okay, but you can't see me. Okay. All right, so how is that going to work? Okay, so if you go to this link, I'm going to do it myself, no problem. So the link to test it out, model testing. Okay. All right. So let me show my face so that you can see me. Let's stop sharing for a bit. Okay, my video is off. Can you see my face now?
Not yet.
Not yet. Okay. Oh, that's sad. Okay, let me go back to sharing my screen. Okay, so that's my face. Yeah, thank you. So there I am. So here's the live inference page, right? So you put that in front of your fruits, of your plant. So I'm going to do one for us right now. Okay. Thank you. All right. This, okay. So I have sorry, I have to share my screen. I don't know how this is going to work. I'm just going to share my entire screen so that you can see what I'm seeing. Yeah. So these images we got. Can you see my screen?
Yeah.
All right.
Ooh, now it got complex.
Yeah, sorry. So these are images we worked with. Yeah. So yeah, we worked with mangoes. We have a lot of really delicious mangoes over here, and then the leaves. Then this was one of the groups. You see the Joseph and Evidence, the people who collected these images. So we have several of them. Some of them at the end of the day, they weren't good, so we had to cut them, but these were the raw images. So now I just point the camera at, I point it at any of these, and it tells me the category that we called it, because when training, what we did was we gave each of those categories their own names. So for instance, this here is a code name to know what kind of plant this is. So it's easier to look up in the database of the plants that we did. So that's how we got everything to work. And here is my, okay, let's just finish the slide so I can show you the hardware itself. So we were able to get an accuracy of 85% on average, right? It was usually and mostly correct, and no false positives, right? So moving forward, we're looking at expanding the database. So this was a test to see if it's possible to pursue this direction of creating this database, which would then help us to do more research and to do more stuff with to do more things with TinyML, right? And this shows that it's very possible because we're able to deploy and see results as we hoped. So we have to expand the reach to get more plants. Like I said, we have diverse species of plants over here, and it's going to be great to be able to point the camera at any plant you see in the university, and then you can just tell that, okay, this is the name of this plant, and these are some information about it when you look up the database that we've put together. And also, we're looking at incorporating GPS for precise location awareness, so you can know this is where this was found and this is where it is. Thank you very much. So now let me show you the hardware.
Great.
Thanks.
Congratulations.
Okay. There.
Oh,
I believe you're familiar with this board, right?
Yeah.
This is the kit. Hi.
that's the chow with an extension board of some sort. Nice. Well, thank you,
Thank you.
Joseph. We are okay time-wise. We've got a couple of minutes where we can ask some questions.
All right.
If anyone wants to start, I do know, Joseph, on these tiny devices that they can be quite accurate when you're classifying one object, but it does get quite complex when you start classifying. It looked like you had about 8, 9, or 10 objects there, and
Yeah,
your results seem really good. Any questions?
A comment that I think is a very important point that Joseph commented in presentation was regarding the data set. In fact, the data set, the get of data set, the preparation of data set, all the pre-processing usually is 70% of a machine learning project. And as you have realized it, Joseph, and as you said, and having a data set is a good data set is a big point for more projects, much more important than the model itself that you have used. So congratulations. I think this is an important find and comment in your presentation for everybody.
Thank you very much. Thank you.
Our next presentation is going to be Franco, and we're going to cut off the recording. Is there anything we want to say before we ditch the recording? Kari, we introduced the lovely slides at the start. Marco, Kari, Marcelo, anything before we dump our recording?
No, we can return after Franco make the presentation. We can return again to close it and see if people have questions.
Okay, sounds good. Yeah, and after Franco's presentation, we can ask questions about any of the presentations. So thank you so much, Joseph. And
thank you,
Franco. Yes. So thank you so much, Joseph, Franco, and the group from TriatoBox. Excellent presentations. And Marcelo, Marco's had to go. Do you want to finish up with something?
Yeah, no, I mean, thank you. Thanks very much for all 3 presentations. Great presentations today. I think that we learned a lot. And I'm very pleased to see the presenters using the devices that our group, the old TinyML4D, now we call AIEng4D. So it's because AI engineering is something more broad, or it's broadly speaking, what we are really doing is using engineering to using AI or machine learning and help the global south to do good things. This is our purpose. Thanks a lot. Okay, we have always remember the participate in what you have done, participate in show and tell. The last week of every month we have the show and tells. Help us to create new contents and new tutorials, and that's it. Thanks a lot. See you in the next time.
Bye, everyone. Thanks for the
Bye-bye.
presentations.
Bye-bye. Thank you, Kari, Jeremy, Marco, and all of the presenters. Bye-bye. Franco, Laila, Joseph, everybody. Thank you.